Let's have a quick review of what we have discussed so far. We said that when we do multiple linear regression, we're trying to describe or establish a relationship between your outcome variable y using independent variables or predictor variables or descriptor variables x1, x2, x3, etc. So if you only have one predictor, x1, then you have what we call a simple linear regression. If you have more than one, then you have multiple linear regression. Now, necessarily guys, yung y natin, yung dependent variable natin, yung outcome variable natin should be a continuous variable. When I say continuous, dapat numerical siya. Hindi siya pa pwedeng continuous, ibig sabihin, hindi siya, it can take the form of a decimal, no? Integer, okay? Pero hindi siya dapat binary, okay? Hindi siya dapat categorical. That's the requirement to do a multiple linear regression. Now, the independent variables, x1, they can take any form. Pwede silang categorical, pwede silang quantitative, numeric, etc. Walang restrictions dun sa mga independent variables natin. Pero yung y natin, yung outcome variable natin, dapat continuous variable. Now, in the event that this becomes a binary, ibig sabihin 1 or 2 lang, o kaya true or false, yes or no, then it ceases to become a multiple linear regression. Magiging ano na siya, binary logistic regression. Okay? So iba yung pag-solve guys ng binary logistic regression, which we're going to discuss in some sessions from now. Okay, kapag yung y naman categorical siya, just like binary, dalawa lang 1 or 2, true or false, yes or no. Kapag mas marami siya, more than 2, then it becomes a multinomial. Okay? So yung isa, yung multiple linear regression natin, dapat ito yung dependent variable natin should be continuous. Okay? Pag pag binary, logistic regression. This requires that our dependent variable should be categorical siya, Categorical na 2 values lang ang pwede. In other words, binary. Like guys, kunyari, we're going to predict if a person will suffer from, let's say, cancer or not. So, dalawa lang yung pwede nun, di ba? Magkaka-cancer ba siya o hindi? Then that falls under binary logistic regression. Pag mas marami naman sa dalawa, multinomial yon, multinomial logistic regression. Okay. Yung dependent variable natin is also categorical. More than 2 categories. Okay. So for example, just you're trying to predict whether a particular respondent, let's see, maybe through the example lang to, if that person or if that respondent is coming from Japan, Korea, or China. Kunyari, ganun lang. So there are more than 3 categories. So Japanese ba to, Korean ba to, o Chinese ba to? So if that's the problem, guys, if that's the what you want to determine, then that will fall under a multinomial logistic regression. Kasi categorical yung dependent variable natin, either 1, 2, or 3. Okay, yung 1, kunyari Japanese, number 2, Korean, number 3, Chinese. Okay, and there are more than 2 categories. Pag dalawang categories lang, then binary. Okay, last time we also studied that for multiple linear regression, there are some assumptions that need to be followed. Number 1, linearity of the data. So dapat yung relationship ng independent variable natin at saka dependent variable natin, dapat linear siya. Okay, nag-plot tayo last time, sabi natin, pag plot natin sa y-axis si dependent variable and on the x-axis si independent variable, we want that the scatter plot show a linear relationship, medyo linear relationship dapat. Of course, not necessarily perfect linear, no? But dapat close to a linear relationship siya. Kasi guys, pag sabi natin, if it does not, sabi natin, okay, asa may annotation ko dito. Okay, where's my annotation here? Okay, sorry, hindi ko makita. Mamaya na lang. No? Okay.
Excuse me, sir.
Yes?
We can't see your screen.
Ay! Wala, naku. Sorry guys. Nag-chat ba kayo saan? Sinasabi niyo sa akin? Hindi pa pala ako naka-share screen. Apologies guys Medyo parang lobot ako mag-isip ngayon, no? Because of the pain. I'm very sorry. Okay, can you see the screen now?
Yes, sir.
Yes,
Okay,
sir.
thank you. Sorry about that. Hindi pa pala naka-share yung screen. Okay, so this is what I wrote, guys. I'm sorry, no? Multiple linear regression, the dependent variable should be continuous, no? Okay, so ibig sabihin nun, let's say ang pinipredict natin, kunyari, let's say stock returns. Di ba ang stock returns, hindi naman binary yan, hindi naman 1 or 2 yan. Ang stock returns, ano yan, decimal places yan, di ba? Percentage, decimal places. Yun, guys. Yun ang multiple linear regression yan. Unless, guys, what do you think? In what instance can stock returns be considered a binary logistic regression? Can you think of any instance, guys, na yung study natin on stock returns will be treated as a binary logistic regression? Anyone? Any guess? Okay, sige. One case wherein we can treat that yung stock returns as binary logistic is if we're looking at it as if it went up or it went down, or if the returns will go up or will go down, diba? So when we look at the data, yung mga returns, kunyari pag negative siya, then it went down. Pag positive siya, it went up. So pwede natin i-predict ngayon yung mga susunod na yung mga future stock returns kung if it will go up or if it will go down. Now since dalawa lang yung possible values, di ba? Up or down lang, then that can be considered as a binary logistic regression. Okay? So pause muna ako. Clear ba yun, guys? Thumbs up na lang, guys. Okay. Thank you. Nag-chat na ba kayo? Okay. Wala pa yata. Clear ba yun, guys? Yung example ko na example ng yung stock returns, pwede maging binary logistic regression. Okay, good. That is, you're not looking at the stock returns itself. We are looking at we're going to classify it. Gagawin natin categorical siya. Pag negative yung stock returns, so it went down. Pag positive siya, it went up. So, bali, kinonvert natin into a categorical variable yung stock returns natin. In that case, pwede siyang gawing binary logistic regression. And yung sabi ko kanina, yung third, yung multinomial logistic regression, this happens when your dependent variable is categorical also. Pero more than two categories dapat. Kasi pag two categories lang, then binary siya. Pag more than two, let's say, yung kanina example ko, no? Kunyari, you're looking at attributes of a particular race or nationality. Sabihin natin may mga variables tayo to use in order to determine if a certain characteristic or attribute is either Japanese or Korean or Chinese. So, yun, tatlong categories yun, di ba? So, pag magmamodel tayo ng ganon, guys, if our dependent variable was categorical, either Japanese, Chinese, or Korean, then that will fall under multinomial logistic regression kasi more than two. Okay. I hope that's clear, guys, yung tatlong klaseng to. We're going to look at this three. No? Titingnan natin kung paano siya pinipredict, kung paano sinusolve. Now, we had last time we said that there are certain assumptions when we use multiple linear regression. Primary is that there should be linearity of the data. When you say linearity, dapat yung dependent variable natin at saka independent variable natin, dapat linearly related sila. Diba? So, pag hindi linear yung relationship nila, then wala na ito, okay. What do I mean by this? So, actually, we spelled this out last time. Diba? Kunyari, ito yung y natin. This is our dependent variable. This is our independent variable. We would want that if we draw a scatter plot between the two, dapat ganito yung lumalabas, no? Medyo may linear relationship. No? Yan. Okay? Hindi pa pwede yung random lang or may ibang pattern, kunyari ganito. Pag ganito, guys, yung pattern ng scatter plot nila, then magpe-fail yung ano natin, yung linear regression natin. Kasi hindi naman linear yung ano nila eh. Hindi naman linear yung relationship nila. If you take a look at this yellow, no? It's more of a polynomial. It's more of a quadratic. Then we should be using a quadratic regression here. Okay? So I hope that's clear, guys. That's what we mean by linearity of the data. Okay, second, linearity of the parameters. What do we mean by linearity of the parameters? Ang yung linearity of the parameters, sabi natin, let's go muna to. See. Diba yung sa equation natin ito? Yan. If you look at B1, B2, B3, they should be in linear form. Ano yung linear form? Dapat hindi siya naka-square root, dapat hindi siya naka-squared, hindi siya naka-cube, no? Okay, itong mga parameters natin. This one, si beta 1, beta 2, beta 3. Okay, when you say linear, gano'n lang siya, no? Beta n. Hindi siya pa pwede naka-beta n to the, kunyari, square root of beta n. Okay? Or log of beta n. Log of beta. Okay. Hindi pa pwedeng transform yung ano natin, parameters natin kasi hindi siya masasolve, guys. It will be very difficult to solve yung parameters natin kasi di ba ito yung mga sinusolve natin. Pag hindi siya linear, it will be difficult to solve this. Okay? That's why sabi natin dito, linearity of the parameters. Okay, this should be very, very clear to us, guys. Hindi pwede natin itatransform yung beta natin. Okay. So, let me run this. Ayaw mag-run. Nag-error siya. Okay, anyway. Okay, I wonder why it's... ang nangyari dito, yan, beta, guys. Your beta is squared. Parang ginawa ko kanina, no? Beta squared, hindi pa pwede yun. Yan, na siya. Yan, beta sub 1 squared. That's not, we cannot solve this, guys. pag ganito, pag hindi linear yung parameters. Now, as I mentioned the other day, guys, diba sabi ko, okay lang, kailan natin to? It's okay if yung si x ang naka-square, si x ang naka-square root, si x ang naka-log, no? Yung mga independent variables natin. No problem with that. Okay, no problem. Okay, ang hindi pa pwede yung parameters natin hindi linear. Okay, so far guys, clear? Paki-chat nga please, paki-thumbs up if you're okay. Okay, thank you. All right. Third, guys, homogeneity of residuals variance. Okay, once we have created our model, sabi natin, pag na-solve na natin lahat ng mga betas natin, na-solve na natin si beta null, beta 1, beta 2, beta 3, etc. So we have solved our regression line. No? Once we have determined yung mga parameters natin, then, since we know the values of x, alam natin yung mga variables natin, independent variables x. Since we know the values of x, so we will now substitute your betas, beta 1, beta 2, hanggang beta n, in order to come up with your y predicted value. Yan. When we substitute yung mga betas natin dun sa mga x's natin, then masosolve natin what we call the predicted value of y. And that's symbolized as y hat. No? Y hat means predicted value. So ang gagawin natin, i-compare natin si predicted value, yung model value natin, with our actual value. Ito yung actual value natin, yung value natin sa data, di ba? So we have your actual value of y. We have your predicted value using the model. Okay, so we compare it. If we get the difference, this is what we call our residuals. Epsilons of I. Yan. Okay, so if we have 200 observations, so 200 sample points, then you will have 200 residuals. Okay, kasi bawat isang actual point, guys, may predicted value yan. So bawat comparison ng actual at saka ng predicted, merong residual. Okay. Tapos pag plinat natin si residual, okay, so we're going to plot the residuals, ano? Dapat, guys, yung residuals natin, dapat constant yung variance. Dapat ganyan yung lumalabas sa kanya. Okay, so this is your residuals. Okay, this can be x. We can plot it to several variables, iba-iba. Okay, yan. Dapat ganyan, no? So, how does this look like? Constant yung variance, guys. It's not increasing over time. It's not going up. It's not going down. Wala siyang parang ganito, no? Kasi pwedeng ganito yung residuals natin, eh. Parang may pattern ng ganito. And if you take a look at the residual that's like this. So, di ba parang may fanning out, no? Parang umaano siya, parang it looks like a fan. Na over time, the residuals, the range, the variance of the residuals goes up, di ba? Ito maliit lang yung ano niya. Maliit lang yung range niya, dito lang, oh. Pagdating dito, tumataas na. Pagdating dito, mataas na. And then over the value of your x, guys. So this is what a condition that we call heteroskedastic. Heteroskedastic yung ano natin. Yung variance ng residuals natin. Heteroskedastic. Skedastic means, guys, yung spread. Okay? So pag sinabi natin yung skedastic hetero, ibig sabihin, nagbabago, iba-iba. No? Unlike yung homoskedastic, same. Same yung spread. So this is homoskedastic, ito. This is heteroskedastic. And we want our model to, the residuals to behave like this. Okay? Pag ganito siya, guys, either going up or going down, may trend na pataas, may trend na pababa, then ibig sabihin nun, hindi acceptable yung ano natin, yung model natin. hindi nakaka-capture ng model natin yung behavior, yung variability ng data natin. Okay. Let me pause, guys. Clear so far ba? Paki-chat naman, please. Clear ba so far yung explanation na yun? Okay, thank you. Okay, salamat, guys. Thank you so much. Okay, so sabi natin, ito, napaka-importante itong condition, no? That the residual should be homoscedastic, no? Dapat constant yung variance yan. Homogeneity of your residual variance, called homoscedastic constant variance. And it's the assumption that the variation in the residuals or the error is similar at each point across the model. Okay. Similar, hindi equal to. Ibig sabihin, may constant band siya na hindi siya lumalagpas doon. Pag lumalagpas na siya, yung spread, pag either yung sabi natin fanning out or fanning in, then sabi natin, heteroscedastic na yung behavior ng variance na yun. Okay? And number 4, we said, dapat yung variables natin, explanatory variables natin, dapat hindi collinear. It should not suffer from multi-collinearity. Okay, if you recall, guys, anong tatlong klaseng type ng data? Anyone, please? Recall last time? Yung tatlong klaseng types ng data natin.
Sir.
Yes.
It's cross-sectional, time series, and panel.
Yes, thank you, Samir. That's very good. Correct. You're correct, no? So it's cross-sectional, and then you have time series, and then you have panel data. Okay, by now, guys, dapat alam natin yan. So, kunyari, bibigyan kayo ng data, dapat madidetermine nyo kung cross-sectional yan. What distinguishes a cross-sectional from a time series? Take a look at the units. No? Take a look at the individual or the unit of interest. Okay, and also the time. No? So, kunyari, you're looking at the performance of macroeconomic performance, in particular, let's say, a GDP, kunyari, no? You're looking at the GDP of several countries. Let's limit our examples to ASEAN. So you have there the countries of the ASEAN, and then you're taking a look at several variables to try to explain the GDP. Tapos tinignan yung time frame, guys. Lahat 2020. Okay, isang time frame lang. Tapos maraming units of interest. Therefore, this is a cross-sectional data. On the other hand, kunyari iisa lang focus, kunyari Philippines lang. And then you're taking a look at it, you're taking a look at GDP from 1970 hanggang 2020. Okay, ito, several points in time na, no? So hindi na siya cross-sectional. Time series na yan. And the last one, guys, is combination of cross-sectional at time series. You have several units, several individuals taken. We have snapshots of them at different points in time. So this is a panel data na. No? Of course, alam natin na, as I mentioned last time, ang pinakamaganda dyan, ang pinakamabas talaga yung panel data. Okay? Panel data is really the for analysis, no, yan ang pinakamaganda. Okay, kaya sa mga papers nyo, sa thesis, usually, madalang yung cross-sectional at saka yung time series. Kadalasan, guys, it's panel data. Kasi mas robust yung information na mabibigyan ng panel data sa atin. Okay, so in relation to number 4, yung explanatory variables are not collinear. So ito, guys, it doesn't have wala siyang masyadong relationship kung cross-sectional yung data natin. Okay? Kung cross-sectional. Wait, sorry. Apologies, guys. I was referring to number 5, yung sa cross-sectional. So sa number 4, guys, we're taking a look at the relationship. I'm sorry about that. Relationship between your independent variables. So labas muna si dependent variable. Tingnan muna natin yung relationship ng independent variable. ideally, guys, we do not want the independent variables to be correlated. Ayaw natin yun kasi parang, kumbaga sa pelikula, guys, mag-aagawa yan, magsasapawan yan sa starring role. Okay, sorry for that crude example, but that's an analogy that we can use. Okay, so that it will be very difficult to say, sino ba talaga nakaka-apekto kay dependent variable natin, kay response variable natin? Si X1 ba o si X2? Kasi highly correlated sila eh. And besides, kung highly correlated sila, bakit natin isasama yung pareho? Pwede isa lang naman eh, di ba? Kung halos pareho lang naman yung behavior nila sa pag-explain kay dependent variable. Okay, we call that, what term did we call that, guys? Kung instead of using X1 and X2, we just use X1 since highly correlated naman sila. Okay, thank you, you. Thank you, you. Okay, anong tawag natin dun, guys? Making our model letter P, guys?
Parsimonious, sir.
Yes, thank you. Very good, very good. That's correct. Parsimonious. Thank you, Samir. Yeah, we want to have our model parsimonious kasi kung pareho lang naman ang pag-explain ni X1 at saka X2 kay kay Y, why include both, di ba? Why include both? Theoretically, guys, parang okay lang naman yun, isama natin pareho. Pero when you're doing actual research, tapos syempre, it will take you time and it will cost you to get data for, let's say, X1. Bakit pa kukunin yung data for X2 kung highly correlated naman yung dalawang yun? Diba? So that requires more time and even more resources. So we're just taking a look at this in the context of actual research, actual study. Okay, so we want our model to be parsimonious. Okay, but of course, if the data is readily available, at okay lang naman kung gamitin natin pareho, and then you'll see that anyway, we'll be able to determine if really both variables are needed. Malalaman naman natin yan by using, let's say, ANOVA, analysis of variance, or kung extraneous na isang variable. Ibig sabihin, hindi naman kailangan siyang isama pa sa module natin. Okay, so I hope clear itong multicollinearity. And sinabi natin, guys, we use a particular measure. If you recall, guys, ano yung measure na yun na gagamitin natin to determine multicollinearity? Ano yun, guys?
Sir?
Yes?
Variance inflation factor.
Yes, thank you, Samir. No? That's VIF. VIF. Okay? So normally your software will generate this. Sasabihin nila yung VIF na yan. Tapos may ano yan, may value, may limiting value yan. Dapat hindi lumalampas yan. Usually ang ginagamit nila 10. But I've seen others use 5. So pag lumampas na 5 yung VIF, ibig sabihin, o 5 or 10, depende dun sa gagamitin natin na benchmark. Ibig sabihin yan, guys, na highly correlated yung dalawang yun. So dapat magtatanggal tayo ng isa. We're going to remove one. Okay, so variance inflation factor. Okay, number 5, guys, independence of residuals. So di ba, guys, pag pinat natin residuals, dapat, guys, si residual na to, hindi siya dapat dependent dito sa previous one. Or itong residual na to, dapat hindi siya dependent dito sa previous one. That's what we mean by independence of the residuals. Okay, now this, guys, is of no consequence. Hindi siya relevant kung cross-sectional data. Okay, bakit? Bakit hindi relevant, guys, tong independence of residuals kung cross-sectional data? Kasi ang cross-sectional data, wala namang wala naman siyang required na order. Kunyari, in-arrange mo na alphabetical yung data mo. Kunyari, ASEAN, alphabetically arranged. It will have this pattern of kunyari, ito yung residuals niya. Pero kung ayusin mo, kunyari, iba-ibahin mo, i-random mo. Kunyari, mauuna si Vietnam. Dapat nasa dulo yun, di ba? Kasi letter V siya. Tapos si Cambodia. Tapos si Singapore. So, random na yung di ba? Random na yung order. So pag magkaiba na yung order ng cross-sectional data mo, edi magkakaiba din yung order ng residuals. Diba? It will take a different shape. Maybe it will be like this. You don't know. No? So, yung independence ng residuals, guys, is of no consequence kung cross-sectional data. It is only of consequence kung time series or panel data. Kasi yung time series, guys, hindi natin pwedeng bagu-baguhin yung order nun. From 1970 to 2020, may structural na order yan. 1970, 71, you know what I mean, guys. No? So hindi pa pwedeng 2019 muna, tapos 1970. Kasi pag binago mo yung order na yun, magbabago yung shape ng residuals natin pag plinat natin. Okay? So pag time series, we don't want na yung residual ng 1972, we don't want it to be related to your residual of 1971, related to 1972, etc. No? So that's what we mean by independence of residual error terms. Now, you notice, guys, na I'm repeating this because we want to put a great emphasis on this, yung assumptions. Kasi hindi lang tayo basta-basta gagawa ng regression model. Kailangan check natin. That's why after we do our regression model, we will have what we call diagnostics. Check natin were these assumptions met. Kasi kung hindi, magkakaroon tayo ng problem sa regression model natin. Lastly, guys, yung normality of the residuals. When you create a histogram or a normal distribution curve, dapat as much as possible, guys, normally distributed yung residuals natin. No? Sometimes, pag yung residuals natin, ganito yung shape. So medyo mahaba yung tails natin dito. Ibig sabihin, concentration ng error terms nasa negative side or opposite nun, nasa right side, then that might indicate that our residuals are not normally distributed. So baka magka-problema tayo dun. But this, guys, is not really a strict, it's not a strict requirement. Kasi pag malaki yung data set natin, kunyari, it runs into hundreds and thousands, okay lang yun. Hindi masyadong problema yung yung normality of the residuals by virtue of what you learned in statistics called central limit theorem. No? Okay? Central limit theorem. We'll discuss this in greater detail next time. Okay, so let's clear na muna yung... Any questions, guys? Okay, chat naman kung clear so far yung 6 na assumptions na to. Any clarifications? Okay, good. Thank you. Dalawa pa lang. Thank you. Thank you, Samir. How about the rest, guys? Thank you, Marielle. Jeff, thank you. Okay, Willie, salamat. Okay, Yung, thank you. And Steph, thank you. Okay, so thank you so much, guys, for your feedback. Okay, let me clear this. Okay, I asked you guys to require the packages. I hope you've already done that. If not, that guys, require. So na-require ko na to kanina. I also asked you to load the okay. You'll have different objects here, guys. No? Yan. Naload ko na si wage, guys. Okay, so we were working with this data set last time. Okay, so na-import ko na siya, guys. Okay, na-view ko na siya. Ito, no? Yung wage natin. Okay, and then we studied last time some functions like yung names, guys. It will give us the variable names of your data. And we looked at the head, tail to display the first elements of your data set. And then yung pag subset, guys, using the brackets, no? Para makuha lang natin yung portion ng data na gusto natin. Okay. Then we learned how to get the descriptive statistics using some functionalities like yung describe function coming from the site package. Sa take-home exam nyo, guys, kailangan, guys, mag-explain nyo yung yung descriptive statistics, yung mean, median mode, average, skewness, kurtosis. So make sure to review a bit about this descriptive statistics, which we're not going to look into anymore, guys, kasi the discussion is in other subjects. Okay, and you can easily, I'm sure, you can easily review that. Okay, so R has a very powerful plotting capability. Dito, pinat lang natin last time yung independent variable natin si hourly wage and si yung unang independent variable natin si years of education. Bakit nga pala natin, guys, pinili si years of education? Why did we choose, guys? Is it here? I think it's here. Well, nauna pala yung plinat natin, ano? But when we got the correlation, so I'll just run this, no? Correlation ni wage, then it includes yung lahat ng rows to, no? Lahat ng rows. Tapos ang columns natin, negative C, concatenate natin 4 to 6. Ibig sabihin nun, hindi kasama si 4 to 6. Okay, kasi we have 8 columns all in all, and we cannot get the correlation of categorical variables. So we're removing this. So when we plotted this, when we run this, guys, saan na siya? Yan. So this is not the correlation. We only have 5 variables here kasi in-exclude natin yung categorical variables. And we're interested in knowing which of these variables are most highly correlated with hourly wage. It turns out that education has the highest correlation. So, kasi guys, sabi natin, maganda kung yung independent variable natin highly correlated with your dependent variable. Ang pinaka, let's say, worst predictor will be number of dependents kasi 0.05 lang siya. Very weak correlation with hourly wage. And then sabi din natin, guys, among the independent variables, ayaw natin na mataas yung correlation nila. Here, it turns out that only tenure and experience are highly correlated. 0.5. Okay, medium lang naman. But we will see, guys, that there might be a problem if we use experience and tenure as predictors. But we'll see. We'll see about that. Okay, so last time, guys, this is what we did. Sabi natin, ang regression sa R. Okay, how do we do regression in R? We'll start first with a simple linear regression. So what we do is we use the LM function. Okay, LM function. We use, we give it a name. We give the model a name. I just call it mod 1. And then what's this, guys? What's the symbol?
Assignment operator, sir.
Yeah, thank you. That's an assignment operator. And how do you write this? Any shortcut, guys? Let's hear from the others. Samir, thank you so much. Huh? Samir has been very active. Thank you, Samir. I also would like to hear from the others, guys. No?
Sir,
Yeah.
I po.
Yeah. Alt what? Alt I, no?
Apo.
Sa Mac, Alt I din, di ba? Or Control I yata, no? Command I. Okay, so that's a shortcut, guys. Huh? Remember that, Alt I, para mas mabilis kita type. And then, ang syntax niya, you start with the dependent variable, no? Hourly wage, and then this is a tilde sign. So this means regress on. So simple linear regression lang muna tayo. Isa lang yung predictor natin, education. And then we have to define what data we're using. Data is equal to wage. Okay, so when we run this, guys, when we run that, lalabas na yung object natin, model 1. Ito, no? And it's a list of 12. So if you study the data structure, guys, yung sa unit 1 natin, there are different types of data types sa R. Meron tayong vector, meron tayong list. Ang vector, guys, it only contains one atomic type. Kunyari, a vector of numbers. So isang data yon, isang data set na lahat numbers siya. A vector of integers, panay integers, a vector of continuous numbers, continuous values. So may mga decimals, a vector of letters, no? A vector of characters, etc. Pag vector, isang klase lang. Pag list naman, iba't ibang klaseng data set, no? Pwedeng may ano siya, pwede siyang may pwede siyang may vector, pwede rin siyang may list, no? If I click this, can you guys, yan, no? So you have here a list, no? You have here a vector, no, ng mga continuous variables. Dalawa yung laman. Residuals, 526 yung laman, no? Okay. Take note, guys, ito, coefficients, double siya. Ang double dyan, ibig sabihin, continuous yung value. Ibig sabihin, it can take on a decimal place. No? Na dalawang value yan. Okay, this is a vector of 2. Okay, this is a vector of 526. Vector siya kasi pare-pareho yung laman niya na continuous. Na pare may mga may mga decimal places. Sa Mac, thank you, Yung, no? Open option command plus I. Yung assignment operator? Or, okay. Okay, thank you, Yung. Option command plus I. Okay. Sa Windows, ano lang, no? Alt I lang siya. Okay. Then here, guys, we have also may mga list tayo dito, may formulas pa nga. Okay, so it takes on several types of data, no? Okay, ito lang, guys, yung residuals. If I click this. Yan, tingnan nyo, guys, no? Ano to? Di ba residuals, yan yung error terms? Remember, guys, yung wage. 526 observations yan. 526 actual value. Yan. 310, 324. So when we did our model, guys, nung nag-regression tayo, sabi natin, di ba, magkakaroon ng predicted values bawat isa niyan. So itong ano natin, isa na yan. Ito, guys, itong residuals natin ito. Ito na yung error terms. No? Ito na yung difference between the predicted value, the actual value minus the predicted value. Okay, so just so we know. No? Okay. All right. So balik na tayo dito, no? So meron tayong model 1 dito. Now we can ask R to print yung output. Okay. Let's print it. Summary, use the summary function. Yan. Okay, gagamitin natin to auto yung summary na yan. Okay, so kinocall niyo muna yung formula natin. Linear model, where hourly wage is regression, education, data is equal to wage. And then here you have a measure of the residuals. Among the residuals, ang pinaka-minimum value is negative 5.3. Ang pinaka-maximum is 16.6. Okay. Then we have this. Ito ngayon yung coefficients natin. Okay. Remember guys, since simple linear regression lang to, ano yung equation natin? Hourly wage, ito yung ano natin, hourly wage is equal to your intercept beta null plus ito yung beta 1 pala, sorry, beta 1 times education. Okay, so this can be replaced by beta null is our negative 0.9. I just use one decimal place plus ito 0.54 times education plus a certain error term. Okay, so this is our hourly wage. So when we predict this now by substituting yung value ng education, pag pinalitan natin yung value ng education dito, then we now have your predicted value. Magiging hat na yan. Mawawala na yung epsilon dito. Okay, this will now disappear kasi predict na natin. No? Okay, let's take a look at one example lang tayo. Oops. Okay, can you please tell me what's the first value in education? Somebody please. Ano yung unang value in education? Sa sample natin. Guys. Hello? Ano yung yung value ng education natin? So first, ano natin? First sample.
$11, sir.
11. Okay. Sige okay, clear ko muna to. Hindi pa pwede ano. Okay, validate lang natin. Yeah, 11, no? 11. So, we'll just prove something here. No? So sabi natin ang model natin is Control C, Control V. So that's the intercept, and then plus. This is the slope for education. Control C, Control V times 11. Okay? Kasi ang equation natin is the intercept plus the slope of education times education. Okay, so para dun sa unang ano natin, for the first sample, for the first observation, the value of hourly wage, predicted value. Ito guys yung HR wage hat. So HR wage natin, HR wage 1, no? Ito yung unang-unang observation natin is equal to 5.05011. Okay? Bakit may hat guys? Kasi predicted to. So that's our predicted value, 5.05. Ano yung ano guys? What's the actual value ng hourly wage? Anyone please? What is the actual value ng hourly wage? Observation 1.
3.10, sir.
3.10. Okay. So 3.10. Sige, tanggalin ko ulit. So, Thank you. Tama, no? 3.10. So, 3, Control C, Control V. Ay, hindi nakuha. Anyway, ito na lang. 3.10 minus yung predicted natin. Control C. Okay, so this is the actual value, di ba? 3.10 minus the predicted value. So we have negative 1.95. This is your error, guys. This is your residual. Kasi hindi niya na perfectly, hindi niya na predict, hindi niya na model ng tama yung actual value. The actual value is 3.10. The predicted value is negative 5.05. That's why if we take a look at the residual here, guys, diba? Ayan, no? Negative 1.9511. Ito yun. That's the residual. Okay, that's the comparison between the actual value and then the predicted value. The predicted value is obtained using our model. Ito yung model natin. Okay, so let's quickly review, guys, yung ano, yung kasi ito, guys, this is an inference, no? So this is coming from a statistical test. Meron tayong hypothesis dito. So ano yung hypothesis natin dito? So our first hypothesis is that here, our intercept, our beta 0, is equal to 0. That's our null hypothesis. No? And of course, we know that our alternative hypothesis now will be beta 0 is not equal to 0. Okay, so ito yung statistical test natin dito. Okay, beta 0 is your intercept. Yun. Now let's infer, guys. Ano yung conclusion natin? We base it on the p-value. Yan. And from your previous study, you have learned that if the p is low, which means pag less than 0.05 yan, if the p is low, the null must go. And so easy to memorize. So if the p is low, the null must go. When you say low, guys, usually it's 0.05, no? So dito, anong conclusion natin dito? Again, ano yung natin, inference natin, guys? Our null hypothesis is that the intercept, beta null, is equal to 0. Now, since the p-value is 0.187, which is greater than 0.05, hindi natin pwedeng i-reject yung null hypothesis. So our conclusion is we fail to reject the null hypothesis that beta null is equal to 0. Ibig sabihin nun, there's a strong statistical probability that your beta null could be 0. Okay? Kasi kung 0 to, guys, yung beta null natin, then hindi papasok sa equation natin yan. However, guys, ito malaking however, when we're analyzing yung intercept, yung beta null, kahit na hindi siya significant, pinapasok pa rin natin siya. We still include it in our model for predictive purposes. Okay? So ginagamit pa rin natin yung value ng intercept. Okay, how about the next one? Ano yung null hypothesis natin dito? So ang null natin dito, since this is HO1, ang null natin, HO2 na tayo, no? HO2. What's our HO2? Our beta 1, which is education, is equal to 0. And then our HA2, alternative hypothesis 2, is that beta 1 is not equal to 0. Okay? Beta 1 is not equal to 0. So what's our conclusion, guys? What's the p-value? Ano ibig sabihin itong 2e to the negative 16, guys? What does this mean? Anyone? What do we call this? Anong form to? Any volunteer, guys? No volunteer? Okay, so, ibig sabihin to guys, yung 2, no? 2 and then negative 16, it means 2 from 2 guys, ito, no? You move negative to the left, no? 1, 2, 3, 4, 5, 6, 7, 8. In other words, guys, 16 places to the left. Or that's equivalent to 15 zeros, tapos 2. So that's a very small number, di ba? That's way, way smaller than 0.05. So ang conclusion natin, guys, for the second hypothesis, where beta 1 is equal to 0, is that we reject the null hypothesis that beta 1 is equal to 0. Okay? There's a strong statistical probability that your beta 1 is a value other than 0. In fact, the average is 0.54136. Okay? So significance beta 1, therefore, it will be part of your model. Kaya nga, yung model natin, guys, how do we write our model? Our model becomes hourly wage is equal to negative 0.90485 plus 0.54136 times education plus a certain error term. Okay, so let me pause for a while. Maybe you're writing notes. Okay, I'll give you 1 minute, guys. And then after that, guys, paki-chat kung okay na tayo, kung clear so far. I'll give you a chance to catch up with your doing notes. If you're ready, guys, if okay sa inyo, clear so far, paki-chat na lang ng yes so that we can proceed already. Okay, thank you, Samir. The rest, guys?
Sir?
Yes?
Nagkaka-error po sa akin na error is in data frame Y. Like, object not found.
Object not found. Sige, use, ano mo I'll make you co-host again. Kindly share your screen. Okay, para makita natin. Let me stop recording first. Clear ko pala muna ito. Stop share muna ko. Sige, can you please share your screen?
Yes po, sir. Like, kahit anong gawin ko,
Object hourly wage not found. Okay. So, tingnan natin Error in hourly wage. Ano yung irinan mo dyan? Ito. Yung sa 144,
yes, sir.
Okay. Sige, akat pa tayo. 125. 125. Notice, di ba, may red bar dyan sa row 125.
Apo, sir.
Ibig sabihin, error yan. Yun yung nasa baba, no? Yung error in plot. Yan,
Apo,
diba?
sir.
Oo. Now, remember, guys, thank you for asking this, no? Remember, guys, na R will not recognize si edu at saka si hourly wage, di ba? Bakit hindi niya mare-recognize? Kasi if you take a look at your environment, sa baba, tingnan mo. Anong object mo dyan sa baba? Hindi, sa baba, sa window pane yan, sa baba, environment. Di ba wage lang andyan dyan, di ba?
Yes po, sir.
Meron ba diyang eduk?
Answer.
Wala. Wala ring hourly wage, di ba? Right?
Wala din po, sir.
Wala. O, kasi hindi mara-recognize yung balik tayo sa 125, no? Sabi natin, hindi pa pwede yan. Dapat yung 127. Go to 127. Yun, dapat in-identify mo kung saan galing yung education, di ba? Galing siya sa sa wage, kaya nga wage dollar education, wage dollar hourly wage. Yan, nag-plot na siya.
Thank you po, sir.
You see the difference, di ba? Kasi dito sa 125, hindi natin linagay kung anong object siya galing. Okay, clear yun? O, ganun din sa baba, no? Kaya nga, yung mali yung 144, ang tama dyan, mali yung 143, ang tama dyan yung, sandali, saan ka na? Okay, dito, anong mali dito? Correlation
Ano pa, sir?
ng education at saka hourly wage yan, okay na yan, no? So, thank you for that question. Very good question. So, guys,
Thank you,
reminder
sir.
sa atin, we cannot just use in a code. Hindi natin pwedeng gamitin sa code yung variable lang, no? So, you have to identify kung saang object siya, no? But recall lang, guys, there's a way to go about it, no? You can use the attach function. Itong nasa 171 sa akin. Use the attach function or in-attach mo siya yung object and then magagamit mo na, guys, na without wage. So ito pwede na yung correlation at saka ng edu at saka hourly wage. Pwede na to. Magagawa na to. Okay. Okay lang to, guys, kung isang dataset lang ginagamit natin. But if we have several datasets, I would suggest that you just go use the yung identifying the dataset where it is coming from. Okay, does that answer your question, you?
Yes po, sir. Thank you, sir.
Thank you. All right. Sige, punta na tayo ulit dito, no? So na-create natin yung model natin, no? Our model is hourly wage is equal to negative 0.90485 plus 0.54 times education plus a certain error term. Okay, now, interpret na natin to. Ano ibig sabihin ng negative 0.90485? What does that mean? What's the meaning of the intercept? Ano ibig sabihin nito, guys? So yung intercept natin na negative 0.90485. What does that mean? Guys, ano ibig sabihin nito? Anyone? Hindi nyo ma-recall, guys, sa nyo? Sa elementary stat nyo? So this is the value of the dependent variable when all the independent variables are equal to 0. Okay? So yung intercept natin, negative 0.90485, that's the value of your DV, which is hourly wage. No? Diba? Dependent variable natin, hourly wage. Okay? When all the independent variable, in this case, isa lang naman, si education, is equal to 0. So how do we interpret that? Okay, so ibig sabihin nun, a person who does not have any years of education will have on the average an hourly wage equal to negative 0.90485. Okay, that's how you interpret it, no? Pero guys, we do not put so much practical significance on that. Bakit hindi pa pwede, guys? Kasi pwede ba naman magkaroon ng negative na hourly wage? Empleyado pa yung magbabayad sa company. Okay, so hindi siya possible, no? So, but still we use it just to interpret, no? Just to interpret the intercept. So the negative 0.9 means that on the average, an employee in this company earns negative $0.9 hourly wage when it has no years of education. Okay? Years of education, 0. Wala siyang years of education. Okay? Sabi nga natin, guys, we don't put much practical importance to this, practical significance, kasi hindi naman pwede talagang magkaroon ng negative na hourly wage. Average lang yan. So what's the meaning of education naman? Yung 0.54. Okay, I hope to get a response from somebody in the class. What's the meaning of 0.54? How do you interpret that? Can anyone interpret this? Hello, guys. Any guess? Any volunteer? Somebody? Okay. Wala. Okay, so ano yung 0.54 na yan, guys? 0.54 is the ano ibig sabihin nito? This is the marginal effect of 1 unit increase in your independent variable on your dependent variable. Let me repeat that. This 0.54 is the marginal effect of 1 unit increase in education on the dependent variable. Okay, so let's interpret. No? For every 1 year increase in education, there's a corresponding $0.54 or 54 centavos increase in hourly wage, ceteris paribus, or all things being equal. Okay, so let me write that. For every 1 year increase in education, there is a corresponding, since money yung hourly wage, no? $0.54 no? Increase in hourly wage, ceteris paribus, or all things being the same. All things being equal, all things being the same. Okay? For every 1 year increase in education, there's a corresponding 0.54 or 54 cents increase in hourly wage. Okay, take note, you have to follow the dimension of the independent variable. So independent variable dito in years. Okay, si dependent variable, alam natin in dollars. Okay, and then we have to include here ceteris paribus, or all things being the same. Okay, this will become more relevant if you have multiple linear regression. Ibig sabihin nun, guys, ang babaguhin lang natin yung variable of interest, education lang. The rest should remain the same. The other variables should remain the same. Okay, so actually, guys, you can determine kung ilan yung magiging increase in hourly wage if you have a 2 year increase in education. Diba? So a 2 year increase in education means approximately 1.08 increase, $1.08 increase in hourly wage. Where did I get that? Kasi 2 years yung increase in education, therefore, si hourly wage mag-increase ng 0.54 times 2. Okay, kasi remember, guys, interpretation ng education dito, 1 unit increase in education, 0.54 dollars increase in hourly wage. Pag 2 units for education, dapat times 2 din itong hourly wage. Okay, so pause muna ako guys. Again, kindly chat kung clear so far. I'd like to see feedback from you guys. Importante ito na interpretation. Okay, thank you. Okay, let's wait for the others. Clear tayo so far. Thank you, Yung. Thank you, Samir. Steph, thank you. Ilan na ba? Willie, thank you. Yung, for, Steph, Mariel. Parang kulang yata yung okay. Jeff, thank you. Okay. Parang may kulang na isa. Anyway, sige. All right. Okay, there's another portion here. Okay, tingnan natin to, no? Ito. Importante ditong portion na to, guys, no? Okay, what's this portion? This one, guys, ito, multiple R squared na to, adjusted R squared, F stat, okay, p-value. This is now the result of your analysis of variance. ANOVA to. ANOVA. Itong kanina, guys, ito, t-test to. So, dalawang test dito sa regression output natin. Ito yung individual test, bawat variable. Ito naman, guys, yung ANOVA, this is the overall. Another name for this is the overall goodness. Sorry for the writing, goodness of fit. Okay. So ANOVA, analysis of variance, this is the overall goodness of fit test. Okay, so this is also a statistical test. So pag may statistical test, merong merong null hypothesis. So ano yung null hypothesis natin dito? As the name suggests, guys, overall goodness of fit. So our null hypothesis here is, so if we're doing this study, HO3 na to. Actually, HO3 na to. Which is beta null is equal to beta 1 is equal to 0. Okay, overall, no? Overall. So lahat ng mga variables natin magkakasama sa isang statement. Ang sinasabi natin dito, all these variables, beta 1 at saka beta 0, are all equal to 0. Of course, guys, ang null hypothesis, alternative hypothesis natin is that at least one of this beta null, beta 1 is not equal to 0. Isa man lang, guys, no? Hindi siya equal to 0. Okay. So ano ba, guys? Anong test statistic ang ginagamit? Kung sa t-test, ito yan, no? T-value, no? T-stat to. Pag sa ANOVA, ang ginagamit yung F-stat. F-stat. So medyo magkaiba yan kaysa dun sa T-stat, no? Dito, guys, kita nyo, dalawang degree of freedom, no? 1 and 524. And ang value ng F-stat natin is 101. 103.4 yung value ng F-statistic natin. Tapos dalawang degree of freedom. Kasi sa F-stat, dapat dalawang degree of freedom ang kailangan natin. You have degree of freedom 1 and degree of freedom 2. Ano yung degree of freedom 1? 1 siya. Okay, ito guys yung natin, yung number of independent variables. Okay, hindi kasama si intercept, ha? Ang number of independent variables natin, si education lang, di ba? So kaya 1 to. Okay? That's where we got 1. Yung degree of freedom 2 natin is your n minus k minus 1. Okay. Where k is your sample size. What's your sample size, guys? Paki-unmute nga. Guys, what's your sample size? Okay, come on, guys. What's our sample size? N is our sample size. Ano yung sample size natin? Take a look at your data.
526, sir.
Yes, thank you. Thank you. You're correct, no? So that's 526, yung N natin. 526. Ilan yung K natin? K is your number of independent variables. Ito yun, yung DF1 natin. K yan. Minus 1. Okay? Minus 1. Kasi pag may predict tayo na kung ilan man yung predictor variables natin, yun yung ibabawas natin sa sample size natin. And then minus 1 again to compensate for the intercept. Kasi isusolve din natin intercept eh. So mawawalan din tayo ng isang degree of freedom dyan. Hindi natin, sineseparate natin siya from K, from the independent variables. So 526 minus 1, that gives you your 524. Okay, doon ang galing yan. Okay? And then we need these two degrees of freedom in order to compute for the p-value. So the p-value is 2.2 e to the negative 16, just like a while ago. It's point and then 15 zeros and then 2. Yun. So this is very, very low. And based on the conclusion that when the p is low, then the null must low. So what's our statistical inference? We reject the null hypothesis that beta null is equal to beta 1 is equal to 0. Reject natin to. No? Reject natin siya. So ibig sabihin na at least one of this, beta null and beta 1, is not equal to 0. Yun lang ibig sabihin. And that's what the overall goodness of fit or the ANOVA gives us here. And then may dalawa pang numbers ito, multiple r squared, 1648, and then 16.32. Okay, ano ibig sabihin ng 16.48? 16.48%. What does this mean, guys? Yung 1648. Anyone? Any volunteer? %16.48%. Anyone? Okay, so in the interest of time, guys, let me answer that already. So 16.48% means that the 16.48% of the variability, the variation of your dependent variable hourly wage can be explained by our dependent variable education. Okay? So ibig sabihin, yung variation ni hourly wage, 16.48% ang kaya niyang i-explain ni education. So, yung 83.52%, hindi niya kaya. No? Ibig sabihin nun, it can be explained by other variables. Okay, so mababa yung mababa yung coefficient of yung r squared, no? Now, dalawang klase yan, yung multiple r squared at saka adjusted r squared. 16.32. Okay, itong adjusted r squared na to, gagamitin natin to, guys, kapag multiple linear regression, no? Okay, we will explain that when we go to multiple linear regression. So that multiple r squared is also called coefficient of determination. Coefficient of determination. Determination. Sorry for the handwriting. And that symbolizes r squared. R squared siya. Coefficient of determination. 16.48. Okay. Pause muna ako, guys. Any naman, guys? Any clarification? Paki-chat naman kung clear o hindi, please. Okay. Thank you, nga pala. 520.
Question po.
Yes.
How did you get for this data? Like the nakalagay yung coefficients, everything naka-calculate na po.
Saan? Sorry.
How did you get for this?
Ito yung output?
Officer.
Okay. Ito yan. Dito. Yung sa LM natin, no?
Apo, sir.
Ito. Yung sa here. Ito. Nag-model 1 tayo, LM, hourly wage, diba? Ito yung sa ano natin, regression natin. And then, summary model 1. When you run these two guys, when you run model 1, well, hindi ipiprint yung output. But when you run summary model 1, yun, ipiprint yung output. I-run mo to. Sino ba yun? Si you? Ikaw ba yan?
Apo, sir.
You have to run this, no?
Sir, for mine po, it says object mod 1 had found naman po.
Okay, sige.
Do I have to
Sandali,
put wage po, sir?
Ano natin, share mo ulit yung screen mo, ha? Guys, I appreciate the questions. Very good. Salamat you for, thank you so much for, nakaka-host ka, di ba? Stop share ko muna.
Ito po, sir.
Ayan, sige. Okay, so mod 1 mo, naran mo na itong, wala ka pang mod 1 sa object. Hindi mo pa naran si mod 1.
Saan po yun, sir?
Yan, yung 159. You have to run that.
Sir.
Sige, control enter mo yan. Kahit anywhere there lang. You don't have to highlight. Sandali. Data is not usage. Data is wage. Wage yung data natin. Sige, run mo yan. Ayan, may mod 1 ka na dito sa baba, di ba?
Yes po, sir.
Tapos i-run mo yung summary. Again, ano ba yung ano nangyari siya? Object mod 1. Kasi ginawa mong MODL eh. So, be careful of the spelling. Okay, tanggalin mo na lang yung L dyan. Sige, i-run mo siya ulit.
Di pa.
Okay, sa 159 ulit muna. You have to run down.
So, run ko muna to.
Oo.
Tapos, ito.
Tinan mo may mod 1 ka na sa baba. Yan na yun. Okay, you.
Thank you po, sir.
Yan, ha?
Sir.
Thank you so much, you. I appreciate really the questions. Very good. Guys, kung may questions kayo, please follow the example of you na talagang tinatanong, no, na pina-clarify. Okay, that's very good. Okay, how about the rest, guys? Any questions? Any questions? All right, I'm going to ask you again. Si Willie, how do you increase the number of the... Willie, pakishare yung pakishare yung question mo sa lahat. Okay, how do you increase the number of decimals sa output natin, sa model?
Yes, sir. Sa summary.
Sa summary, no? Ito.
Yeah.
I-increasean pa.
Yes, sir.
Okay. Let me see. Okay. Iba-iba kasi yung niya, no? Iba-iba yung... Okay. To be honest with you, I haven't tried that before. Pero tingnan natin, ha? Let's see. Maglalagay ako ng round dito. No? Kasi the round function will give us tapos sabihin natin 5. Tingnan ko kung mag-run to. I'm not sure if yung round kasi may mga pinipilian siya ng mga functions na pwedeng samahan. No? Let's see if this will work. Ayaw, no? Ayaw. Okay, so gawin na lang natin assignment siya, no? How do we increase? Thank you. Sandali. Sino yung tanong? Thank you, Willie, for that question. No? Okay, so ang question ni Willie, how do we, if we want to increase the number of decimal places, or for that matter, decrease, no? How do we, dito sa summary, no? Dito sa output. I haven't encountered that. No? Kasi usually, guys, para sa akin, sufficient na yung output ng summary. But that's a very good question, Willie. So we'll do that. Tingnan natin itong before we call it, we have a short break. Let's use JTools. Okay, I don't know if we try to run this, no? Na-install nyo na ba itong JTools dati? Okay, kung hindi guys, i-install that packages yung muna, then i-library natin. Tapos JTools, again, punta muna tayo dito. JTools. It's always a good practice to seek the help, no, of the tutorial. Okay, ayaw daw, kailangan dalawang pag-package, usually dalawang question mark. Okay, while it's loading, guys. Okay, ayan, JTools. Hindi niya binigay yung JTools talaga, no? Okay, and sometimes it's better to get help dito sa packages mismo, no? Let me type JTools here, JTools. Ayan. And naka-load na siya, naka-check na, no? But I'll just click this. Ayan, okay? So it's used for analysis and presentation of social scientific data. So pag nagpe-present tayo ng mga tables, ng mga ano, may description file dito, may user guide, I leave you guys to look at this. Ito yung mga functionalities yun. Pag sinabi kong functionalities, ito yung mga functions na pwedeng gamitin sa ano, sa R. Okay? Example, add grid lines, add X grid lines. So maganda itong pang-plot. Okay, let's use JTools now and use the sum function. Kailan natin yung sum function dito. Yan, no? Yan. Sum function, if we click this, regression summaries with options. Okay? So sum.lm, so depende dun sa type ng ano. To get specific documentation, choose the appropriate link to the type of model that you want to summarize. Okay, so we can either use sum, okay, or sum.lm. Pwede rin to. Okay, so mas maraming pwedeng idagdag. No? But let's just run this. Okay, and then here it will give us yan. Kaysa yung kanina, di ba, yung sa summary natin, hindi siya maayos. Ito mas maganda yung mas maganda yung pagka-present. No? You have the model info observations 526, dependent variables hourly wage, type is OLS linear regression. So you can see here the ANOVA, no? ANOVA result. F, degree of freedom 1, degree of freedom 2 is equal to, ito yung F stat natin, 103.36. P-value is practically 0. R squared, 0.16, adjusted R squared, 0.16 then. And then this is our individual t-test. Estimate, standard error, p-value, and then the probability. Tingnan natin guys yung digits dito. May ano ba siya for digits? Digits. 2. So ito pwede natin idagdag to guys. Dadagdagan natin. Control C. Comma, Control V. Digits is equal to, gawin natin 5. Okay, saan ko nakuha to guys? Dito sa tutorial. You can add other parameters. Yan. Pwede natin ibigay yung yung confidence interval. I-run muna natin to, no? See this? Yan. And you can see here nadagdagan yung nadagdagan yung decimal places. Okay. Yan. So in consonance with, depende dun sa function na ginagamit natin. So this was the question of really a while ago. So if you're using the JTools package, ito yung sum niya. Ito guys, may VIF pa nga. Oh. Okay, ito yung sinasabi ko. Mamaya siguro tingnan natin, gamitin natin to. No? Ano pa pwede natin i-ano dito? Ilagay. Lagay natin yung ano, yung confidence interval. Okay, let's see. Let's write this. Control C. Tapos I'm going to i-true natin to. True. Para malagay yung confidence interval. And then yung confidence interval with okay, 0.95. Okay, so tutorial talaga nakakatulong guys kasi makikita natin kung ano pa yung mga pwede nating ilagay. No? So let's run this. Okay, then magdadagdag siya ng ano. Yan, tinan nyo guys. So, naglagay siya ng confidence interval. No? Ito yung estimate. And then, ito guys, makikita natin dito, 5% confidence interval. You can see here that the value of your intercept lies between negative 2.25 and 0.44. And then, kaya nga hindi ito significant kasi tatamaan yung zero in between this. Sa education, hindi tatamaan. 0.43 to 0.64, no way that for zero to be hit by this confidence interval. Okay, so I just show you an example, guys, of how to make use of how to study this. Tapos pwede kayo mag-experiment, tingnan nyo. Tapos meron ano naman yan, may tutorial, may mga information, may mga definitions. So it's just a matter of really wanting kung ano ba talaga yung gusto nyo. Okay, ngayon ko lang itong 4 na lang para masyado malaking 5. Yan. Yan, 4 decimal places lang siya. Okay, and it's a lot better than the one we used a while ago, yung summary lang. Okay, so let me just recapitulate that, guys. Yung ginamit natin yung JTools na package. Ito. Tapos maraming functionality. Tinignan natin yung sum. We looked at the summary. So instead of using just the summary function dun sa sa basic R, ginamit natin yung summary function ni JTools. And you come up with better tables and better outputs. Mas maganda siya kasi nakatabular yung kanina hindi maganda di ba? Yung sa summary function. Okay, ito. Let me remove this kasi hindi nag-work itong round dito. Okay, tingnan natin yung output ng summary, diba? Tingnan natin yung output ng I'll run this one here. Okay. I just want to compare guys yung tingnan yung output na to vis-a-vis this one. So di hamak naman na mas maganda tong using JTools. And also you can modify, di ba? You can add some more elements that you wish to add. Okay, you can do that. All right, so again guys, paki-chat nga kung clear so far. Okay, thank you Samir, thank you. The rest, paki-ano naman guys, paki-feedback naman please. Thank you, Mariel. Steph, thank you. Jeff, thank you. Yung, thank you. Okay? All right. Sige, tinan ko lang to tapos, let's see. Okay, i-run lang natin to and then let's have a brief break, guys. Okay. So, ano yung names ng Model 1? Diba? Tinignan natin to kanina, diba? Yung sa, ano? When we look at this, oops, sorry. Yung Model 1 natin, diba? Ito yun, diba? Ito yung mga laman niya, diba? Okay, so it will give us the names. It includes, ayan, no? Coefficients, weighted values, etc. Ito yung mga laman niya. Okay, and then you can, kunyari, ito kasi yung coefficients, it's inside Model 1. So you remember, guys, how do we get? You can use Model 1 and then dollar coefficients. This will give us the value of the coefficients. Yan, dalawa. No? If you want the residuals, mahaba yan, 526, diba? Yan. This will give us the printout of the 526 residuals. Ito yung difference ng actual value and your predicted value or model value. Okay, and then we have your fitted values. Ano yung mga fitted values? Ito yung mga predicted values. 526 din yan, guys. So, kinumpute din niya. Ito yung unang kinumpute natin kanina, naalala mo? So, you can also get the predicted values. Or, ang tawag sa kanya, fitted values. Then, we have two measures here, AIC. Sabay ko na itong AIC at saka BIC. Yan. So, what's AIC? Haka-IK, Information Criterion. And yung isa, Bayesian Information Criterion. So that's what Haka-IK means, no? Ilagay ko pala dito. Haka-IK. Haka-IK Information Criterion. And this one is Bayesian Information Criterion. So we're not going to study how this is computed. May formula yan. Pero where is this used? Yung Haka-IK at saka BIC. Haka-IK and BIC, guys, is used when you're comparing models. Okay? So when you're comparing models, guys, then we access the AIC, and the lower the AIC, the better. Kasi this measures information loss. So the lower the AIC or the BIC, the better. So just remember that. Mamaya pagkatapos ng break natin, babalikan natin to. Okay. Okay. What time is it? Okay, so sige guys, let's have a quick kahit 10-minute break, guys, no? Okay lang sa inyo, guys, or would you want, wag na lang 15, ha? Kung pwede 10-minute break lang, okay lang. Just to refresh a bit kasi medyo sabi ko nga medyo highly technical tong discussion natin, no? Will that be okay with you guys? So watch ko is 9:51, so let's resume at 10 o'clock, 10:01. Okay, sige. So break muna tayo ng konti. Guys, request lang pag balik natin, paki-remind ako na na resume recording ko kasi ipopost ko muna yung recording. Okay, sige. Let's have a 10-minute break.
Sir,
Yes?
yung sa JTools, yung sa bottom right.
Yeah.
Saan mo nahanap yun? Kasi iba yung lumabas sa
JTools, sino to? Si you?
Willie.
You? Sino?
Willie.
Willie. Willie yung JTools, kailangan i-load muna natin to package to.
Yes,
So,
sir.
in-install mo na siya.
Yes, sir.
kung saan ko nakita yung help, no? Yung ba yung question mo?
Yes, sir.
Okay, dito, pwedeng gawin natin dito. Dito sa help, no? O sa packages, go to packages, hanapin mo si JTools. Okay?
Yes, sir.
So, makikita mo siya dito, no? So, sabi nga, analysis and presentation of social scientific data. So, you click this. Click JTools. Yan. Nandito na yung help function ni ano. Okay, so you can click description file para more information about JTools. Tapos may user guide, packaged vignettes, no? Other documentation. So maraming pwedeng, if you really want to study the package. But for us, we'll just limit it to, kasi ang tinitinda lang natin kung paano natin magagamit si JTools to create the regression output, no? So ang function yan yung sum, yan.
Okay, nahanap lang.
Ito, no? Regression summaries with options. Pag clinic mo to, yan. So, andi dito siya. Tapos, meron ding ito generalized list linear model. Pwede natin maggamit yung sum.lm. Pag clinic mo to, yun. Ito yung mga pwede natin idagdag, no? So, ito yung function niya, sum, and then model, yung model natin mod1, and then you can choose any of this, no? Choose natin si digits. Choose natin si confidence interval. Choose din natin si confidence interval width. Okay? So, yun ang dinagdag natin.
Okay, sir. Thank you.
Okay, thank you, Willie. Any other questions, guys? Sige, break muna tayo, ha? Pause recording. All right. So you can see, guys, that R is a very powerful software. We're just even looking at a simple linear regression. How much more, guys, kung mas complicated ba na mga models, which R can also do. And besides, as I said, it's freeware, so you can, and there are lots and tons of tutorials already out there sa YouTube, so you can easily learn more about R. Now we can plot the regression line. So in this code, guys, do you have this in your do you have this, guys, in your file? Meron ba kayo nito, yung plotting the regression line? If not, guys, I'll give you a few seconds to copy. The reason why I'm putting most of the codes in blank is for you to practice, no? Importante na pa-practice nyo rin yung pagsusulat ng code. Later on, pag medyo we get the hang of it already, what I'm going to give you to save on time is yung my codes na, no? But for now, tinan ko nga kung binigay ko sa inyo, may ganun ba? Okay, wala, no? Ito yun, plotting the regression line. So, see, guys, I'll give you a few seconds to copy this. So we have here plot, and on the x-axis is your education. Kailangan din natin wage, dollar education, wage, dollar hourly wage. On the y-axis, ito din yung parang similar lang sa taas kanina, guys, no? And we're going to put labels x-axis, years of education, labels sa y-axis, hourly wage, and then we're using the plot character yung 19, yung ginamit natin dati. Then do not put a frame, and then the main plot would be titled scatter plot of education and hourly wage. And then if you recall this, actually pareho kung nasa taas, guys, so you can just copy the previous one. Ito lang idadagdag natin, no? AB line. And then, maglalagay tayo ng regression line, LM, hourly wage, regress on education, and then let's give it a color blue. Okay, and once you have run this, once you have written this, let's run this. Okay, saan ako nagkamali? Wage, education, wage. Okay. Kulang ako dito guys. No? LM hourly wage, dapat may data tayo dito. Data. Okay. Ito hindi na na-recognize. No? I forgot to put the data here. Okay, so let me run this again. There. Okay, so once you have generated the plot, kindly chat please kung okay na. I hope everybody's following. Kindly chat guys kung yes na, kung if you were able to run already. Thank you, Yuj. Let's wait for the others. Okay, good. Mariel, thank you. Samir, thank you. The rest, waiting for the others for their feedback. Lima hindi pa nagpo-feedback. No? Okay, kamusta yung iba, guys? Nagawa niyo ba? Thank you, Steph. Yung, thank you. Jeff, thank you. Okay, so I hope the others are following. No? Okay, tingnan natin to guys, plinat natin yung hourly wage on the y-axis, years of education on the x-axis. And then sinama din natin sa pag-plot, we also plotted ito, no? Yung AB line na to, it will plot a line, depende kung anong line, ito, no? Pinapaplot natin yung line ng regression line. No? Okay, LM, this is from our model, di ba? Linear model. Okay, and then we made it color blue. So ito yung regression line natin, guys. Ito yung regression line natin, itong blue na to, no? This one. Okay? So, andyan yung mga predicted values natin. Mali. Yan. So ito yung regression line natin, no? Pakatang ko rin, hindi makita. Okay. So this line is your, ito yung hourly wage is equal to negative 0.90 plus 0.54 times education. Ito yung line na yun, guys. Yeah, if you check, if you continue this, kaya nga intercept niya. Intercept niya, andi dito, here, somewhere negative. Kaya nga negative yung intercept natin. Okay, now, ito yung, natin, ito yung regression line, ito yung predicted, andito yung mga predicted values natin. Yung difference between the actual value and the predicted value, yan yung mga error terms natin, yan yung mga residuals. So there are some correct predictions kasi nasa line sila mismo, yung mga points na to. No? Any point here on the line itself, they are correct predictions. May mga malalapit lang yung prediction, so ibig sabihin maliliit yung error terms, but there are those that are really far. So, yung distance na to, ito yung actual point, and then ito yung regression line. This seems to be the highest na residual. Hindi, ito pala. This one. Difference niya. That's, sabi kanina, di ba, mga 16 siya. Okay, so, all right. So we don't okay. Let's keep this first, itong residuals, no? Babalikan natin to next meeting. What we're going to do first is we jump to ito. Magmo-model 2 tayo. Okay, let's keep the residuals. Yung diagnostic analysis. Okay, remember guys, once you have done the regression, what you do is you don't stop there, you diagnose. You check for the conditions of the model as regards the assumptions of classical linear regression model. So let's skip that first, yung unang residuals natin, kasi isang simple linear regression lang yan. What we're going to look at is the diagnostics of the final model. Okay? All right. So let's take a look at this one. Model 2 na tayo. By the way, here, we can check the correlation among the explanatory variables. So site package, merong function appears that panel. Okay, psych, and then pairs that panel, and then wage. So kindly write, I think Did I give this to you? Do you have this code chunk, guys? Meron ba?
No, sir.
No, sige. Okay, so hanapin nyo nga guys yung ano, bago yung check correlation among explanatory variables. So we're going to skip the, ito, no? Sandali. We're going to skip this, itong mga diagnostics, and then we'll first go to ito, multiple regression. Okay, we're still going to use the same data, wage data, and then we're not going to do, unless you have, if you haven't run this, guys, i-run nyo muna, no? Ito yung ginawa natin last time. What's this for? Para saan to yung as that factor? Remember, these are categorical variables. And categorical variables may be used in a multiple linear regression as independent variables. However, kailangan naka-factor siya. Data type siya, dapat factor. Hindi siya pwedeng character. So let's check muna. Let me check here. Control-Alt-I. Okay. By the way, kaninang Control-Alt-I, hindi siya yung hindi siya yung assignment operator. Yung siya, yung code chunk, no? Shortcut ng code chunk. So let me check yung class ni wage raise. Let me check. Okay, factor na siya, no? Kasi naran ko na kanina yung na-convert ko na siya as a factor. In your case, guys, kung character pa rin, then you will have to run this. Kailangan ma-convert natin si race, si gender, si civil status as factor. So if I take a look at the structure, yan, naka-factor na siya. Race, gender, civil status. Okay, sige guys, I'll give you a few minutes, few seconds. When you're done, pag na-check nyo na kung factor na siya, then please chat. Okay, thank you, Samir. Okay, thank you, Willie. Let's wait for the others. Thank you, Marielle. Thank you, Yung. Steph, thank you. Okay, let's give a few more seconds to the others. Jeff, salamat. Okay, meron pa ba? Okay. Yan. You, thank you. All right. So, we can now proceed, guys, with the multiple linear regression kasi yung mga wage, yung mga race, gender, civil status, they have been converted into factor. Now, hindi ko na ipapakita, guys, pero if you try to experiment and ibalik nyo siya as character, no? Yan, gawin yung as that character. Binalik nyo na naman si race, gender, civil status as character. And then you try to regress, guys, magkaka-error terms. No? Magkaka-error yun kasi hindi natin pwedeng gamitin yung character as a regressor. Dapat naka-factor siya. Okay, so let's run this using the psych package. Let's take a look at yung pairs that panel na correlation. Okay. So let me just highlight this. Okay. So dito guys, makikita natin yung distribution ni education, experience, tenure, si race, gender kasi di ba binary lang yan eh. Ano lang siya, kasi si race, white or non-white. So count lang yung binibigay sa kanya, no? Civil status. And then the rest you can see the distribution. Now, tignan natin guys yung sa taas ng mga numbers sa to, you can find here the correlation. Kunyari si education at saka si experience, -0.3. They are negatively correlated. Tapos asa na si tenure? Si tenure at saka ito yung mataas, no? sa tenure at saka sa experience, no? So it's 0.5. 0.5 yung correlation niya. Okay, so this is a pretty good chart, okay, showing the distributions of each of the variables, and then on top you have the correlations. Okay, so sabi natin, si hourly wage ang tinitingnan natin, maganda kung matataas to, no? Ang pinakamataas na si education 0.41, followed by tenure 0.35, tapos si gender 0.34. Okay, guys, hold on, just a minute. Okay, sorry about that, guys. Okay, so now we're going to do now our next model. Let's call it model 2. Tanggalin ko lang yung parenthesis dito. Model 2, and then same thing, guys, LM. Hourly wage is, we're going to regress hourly wage on education plus experience plus tenure plus race plus gender plus civil status plus number of dependents. So 1, 2, 3, 4, 5, 6, 7 predictors. Data is equal to wage. A shortcut for this, guys, is ito, no? LM, hourly wage, tilde, and then dot. Pag sinabing dot, guys, ibig sabihin lahat ng ibang variables. Okay? Here we just spelled it out. Okay, so let's run this. Model 2. So meron na tayong model 2 din dito. Yan, model 2, no? And it's a list of 13. And then we'll not run this anymore, pareho lang yan. And then kunin natin summary, no? Summary ni model 2. Okay, which is yan. Or while we're here, copy natin, guys, yung ano natin, si JTools, no? Para masanay tayo dito sa, maganda kasi output ni JTools. Kasi yung code natin kay JTools. It's here above. Ito, no? So I'll just copy this. Control C. Okay, I'll run it here. So, model 2, no? Model 2 na to. Okay, so this is the result of our regression. And I'll use this, si JTools natin. sum function ulit for model 2, 4 digits, may confidence interval, tapos may width. So let's run this. Okay. There. Okay, I think ang pangit lang dito guys, hindi niya linalagay kung ano, kung significant o hindi. Diba? Dapat sana may maganda kung may asterisk. But I don't know. What we can do is research kung paano siya ilalagay dito sa sum ng JTools. Linalagay ba niya? I'm not sure, no? But we can check it out, no? Not here, but outside. Tignan natin, guys, i-research natin. Kung pwede ilagay ni JTools yung kung significant o hindi with the ano. Kasi dito, guys, makikita natin. Sa summary function ni R, ng LM function natin, 3 stars, di ba? Ano ibig sabihin ito? Significant at 0.001. Ito dot significant at 0.1. Ito yun. 3 stars ito. Okay, so you have here, guys, ilang variables na 1, 2, 3, 4, 5. Tatlong variables sa significant at 0.001. Si intercept significant din. Si tenure significant siya at kung 10% yung gagamitin natin. The rest are not significant. Okay? All right. So quickly, let's analyze this. Ano ibig sabihin ng negative 3.38958? Ibig sabihin, guys, I'll not write it anymore, guys. Just be sure you know how to interpret this. This is the hourly wage. No? Hourly wage. Okay, if all these variables are all equal to 0. Okay, so education, experience, tenure, race, white, gender, male, civil status, number, dependents, they're all equal to 0. Okay, now it's important for us, okay, before we interpret, guys, before we interpret this, what happened to our race, gender, and civil status? May nangyari sa kanila, no? Ano ibig sabihin nito? Ito, nagkaroon ng race, white, gender, male, civil status, single. Bakit na-attach yung isang ano? Yung isang level ng variable? Bakit na-attach? Okay, tingnan muna natin, ha? Let's see. I think it's levels. Levels ba level? Levels. Okay, levels. Levels ni wage, dollar, and then race. Okay, so what does this code give us? Okay, so dito sinasabi sa atin kung ano yung different categories dito sa kay race. Meron tayong white at saka non-white. Let's copy this. Let's this time take a look at gender. Ano yung level si gender? Male, female. Tapos yung isa naman si civil status. Okay. So ito, guys, the factors, yung mga categorical variables sa ginawa natin factors, tagalawa lang yung ano nila, no? Tagalawa lang yung levels nila. Non-white, white for race, for gender, female, male, at saka for civil status, married, at saka single. Okay. Anong ginagawa ni ano dito? Anong ginagawa ni R? What does it mean for a categorical variable to be converted into a factor? So what happens, guys, is nangyayari yan, dinadamify yan. Damify. Okay, so R will convert into dummy variables. So gagawin yung dummy variables, itong si race, si gender, at saka si civil status. Ano yung ibig sabihin ng dummy variable, guys? It will be converted into 0 or 1. Okay? So dummy variables would be converted into 0 or 1. So how does that happen, guys? How does that happen? Take a look at this. Si race muna, no? Di ba non-white at saka si white? Okay? Non-white at saka si white. What will happen? Ano mangyayari dito? If you take a look at the result, makikita natin na ang ginawa niya, race white. No? Race white. So what does this mean? Ang ginawa niya dito, guys, kung sino yung wala dito, yun ang gagawin niyang 0. No? So ang ibig sabihin dito, ang ginawa niyang 0, si non-white. Okay, bakit na pinili si non-white? Ang default ni R, guys, kung sino yung alphabetical na na mag-a-appear first, siya yung magiging, ang tawag sa kanya is benchmark or reference variable. Okay? So let's take a look at race, no? So si race, dalawang klase yan, si non-white at saka si white. Okay? Ang tanong unang-una, ilang dummy variables ang i-introduce? How many dummy variables are going to be introduced? There will always be L, yung levels, no? -1. So kung dalawang levels, guys, non-white at saka sa white, ang dummy variable na mangyayari, guys, is only one variable. Kasi dalawang levels, -1. Okay? Dalawang levels, -1. Alright, so anong ginagawa ni dyan? Anong gagawin ni R? Paano i-damify? Okay, so how this will be damified is this, no? Okay, so mag-introduce ng panibagong variable. Ang ginawa dito ni R, tinawag niyang race white. So race white, no? So ang mangyayari, guys, papalitan tong variable natin na race. Papalitan siya, gagawin siyang race white. Okay? So how will that happen? I-click mo nga ito. How will race white happen? Ganito siya. Okay, let me go here. Right, annotate again. Okay, so please bear with me, guys. Importante itong explanation na ito, no? So ito si race, no? So parang gagawa siya ng panibagong variable. Okay, shortcut na lang race white to, no? Bakit white yung pinili niya, guys? Kasi ang mangyayari dito, yung alphabetically na mauuna, siya yung gagawing reference. Pag sinabing reference, guys, gagawin siyang 0. Gagawin 0 yung value niya. Okay, so ito yung race white, no? So, si non-white magiging 0, si white magiging 1. Okay, ito white, di ba? So, ang value nito 1. 1. Ito white, 1. So, lahat ng white, guys, 1 lahat yan. 1 lahat. Tapos, si non-white, guys, magiging 0. So, lahat ng non-white, 0. White, 1. So, ganyan, no? Ganyan. So, you notice, guys, we only introduced one variable in order to replace race. This is now what we call your dummified variable. This is your dummy variable. So, kinonvert siya into zeros or ones. So, since parang ano na rin siya, no? Parang, ano na rin to, numeric na rin, no? Kasi pag characters hindi pa pwede isama eh. So, kinonvert siya into ones or zeros. Ilang variable lang i-introduce? Isa lang, no? Bakit naging isa lang? Kasi ang formula, kung ilan yung levels, -1. So, kunyari yung variable mo, 5 yung levels. Therefore, 5 dummy variables ang i-introduce dun. Okay? So, I hope that's clear, no? 5 dummy, 4 na. So, kung 5 levels, 4 na dummy variables ang i-introduce. I'll show that in a while, no? Okay, so si race dito, naging ganito na siya. Isa lang siya, isang dummy variable. Okay, pero yung white lahat naging 1, yung non-white naging 0. Anong ginawang default ni R? Lahat ng mga nauuna alphabetically, siya yung gagawing 0. Tapos lahat ng otherwise, siya yung magiging 1. Okay? Ganon din si civil status, guys, o si gender. Si gender, female, male. So, ang mangyayari dyan, sino yung magiging reference? Pakisagot nga, guys, yung tanong ko, sino yung magiging reference dito sa female at saka si male? Sana pakisagot, guys, ha? Dito sa gender na to, sa variable na to. Hello? Guys? Sa gender, sino yung gagawing reference variable?
Sir, you said po na alphabetical siya.
So sino nga?
Di ba po dapat F mauna?
Yeah, F. Therefore, sino yung reference?
Sino po, sir?
Si female, guys. No? We're taking a look at R, guys. Baka ibang software, iba yung method nila. Kaya R, titingnan niya kung sino yung alphabetically mauuna. Since si female ang mauuna, gagawin niyang 0 to. Si male ngayon yung gagawin niyang 1. So pag magdadamify tayo dito ngayon, gender, gagawin niyang gender. Ang default na pangalan niya, gender, male. Ibig sabihin si male, siya yung magiging, ang value siya magiging 1. Okay, so let's convert this, guys. 0, okay. So ito yung natin, gender, male. Bakit male? Kasi si male yung hindi benchmark. Okay. Ito, female. Anong value niya? 0 yan. 0. Next, female. 0 din siya. Next, male. 1 yan. So, lahat ng male dito mga susunod, 1 to dito. 1, 1, 1, 1, 1 yan. Lahat ng female, so 0, 0, 0, etc. Okay? So, just by introducing one variable, guys, captured natin yung scenario na male or female siya. Captured to. Okay, so hindi pa pwedeng dalawa, guys, ang ipapasok natin. Hindi pa pwedeng female at saka male. Kasi kung tutuusin, pwedeng ganito female, male. So kapag female, lagay natin dito 1, so therefore 0 to si male dito. Female ulit, 1, 0. Male, 0, 1. Diba, guys? So ito yung scenario na dalawang pinasok natin na dummy variables for the 2 levels. Now, hindi pa pwede yan, guys, kasi magkakaroon tayo ng what we call dummy variable trap. So saka ko na i-explain yan, guys, kasi hindi pa natin magagrasp fully kung ano ibig sabihin nun. Suppose it is to say, guys, na as to the question, ilang dummy variables ang ipapasok? Ilang dummy variables ang ipapasok? So, hanapin niyo muna kung ilang levels. Levels minus 1. So, kung dadalawa lang levels niya, 2 minus 1, you'll only have 1 dummy variable. Okay? Now, suppose you have another variable. Kunyari, level. No? Kunyari, year level. Kunyari sa college. No? So, may mga frosh, sophomore, junior, senior, frosh, sophomore, junior, etc. Okay, yan. We have 4 levels there. Frosh, sophomore, junior, senior. 4 na levels. Ilang dummy variables yan, guys? Paki-chat nga, please, kung ilan. Come on, guys. Come on, kaya niyan. 4 levels. Therefore, ilang 4 levels? Frosh, sophomore, junior, senior. Ilang dummy variables ang ipapasok? Yes, thank you, Samir. Yung iba hindi sumasagot, guys. Ilan? Yung iba, sagot nga, please. How many levels? Hello? You still there, guys?
Sir, ano po ulit yung question?
You have a variable, year level, no? Year level, tapos ang mga level siya, frosh, sophomore, junior, senior, 5. Apat na levels. No? Ilang dami variables ang i-introduce ni R? 4 levels, therefore 3 variables. Yes, correct. U, ano lang 3 lang. Kasi di ba ang formula, kung ilan yung levels, minus 1. If you're answering the question, how many levels? 4, okay yun, tama. But if we're asking the question, how many dummy variables will be introduced? The answer is, there will be only 3 dummy variables. Saan nakuha yun? Levels, number of levels, minus 1. Okay? So, sige, i-check nga natin, guys. I-check natin. So, anong gagamitin ni R? Sino yung magiging dito, benchmark? Since si Frost yung mauuna, therefore, ito yung gagawin niyang benchmark. Ibig sabihin, gagawin niyang 0 si Frost. So, ang mangyayari dito, so level, and then sophomore, no? Level, junior, level, senior. So, tatlo lang, guys. Tatlo lang yung natin, yung magiging, yung magiging dummy variables. Ano mangyayari dito? So, si Frost, guys, what will be the value of Frost? Hindi siya sophomore, hindi siya junior, hindi siya senior. So, 0, 0, 0. So, pag nakita natin na itong tatlong 0 na sophomore, junior, senior, 0 siya, that means that it's a Frost. So, na-capture yung ng Frost. If you take a look at these 3 dummy variables, captured lahat yan. No? How about the Frost na naman? So, 0, 0, 0. How about sophomore? 1, 0, 0. Diba? So, sophomore, 1 siya. Yung junior, 0, 1, 0. Senior, 0, 0, 1. So, kung saan siya, guys, kung saan siya papasok, 1 siya dun. Pero si Frost, guys, 0, 0, 0 lahat. So, if R reads this 0, 0, 0, 0, alam niya na, Frost to. Si Frost na naman, 0, 0, 0. Sophomore, 0, 1, 0, 0, 1, 0. Sophomore pala, mali. 1, 1 to. 1, 0, 0. 1, 0, 0. Si junior, 0, 1, 0. Okay, guys? All right, so that's what we mean by dummyifying. So ano yung mga dinadamify natin? Yung mga variables na characters sa pwedeng i-consider na factors na classifier. Kasi importante yan, kasi baka iba yung hourly wage if you're a Frost, or if you're a junior, if you're a senior, of your male, a female. So tinitingnan natin yun kasi pwede magkakaiba yung mga yun. No? So we can use that levels to determine if is there a difference between a junior, a senior, or a sophomore in terms of hourly wage. Okay, pause guys. Pakisagot naman guys kung clear so far. No? I will have to see all of you answering this guys. Clear ba so far tong dummy variables? Samir, thank you. Yung, thank you. You, Willie, Jeff, Steph, Sam. Okay, may kulang pa. Sino pa yung kulang? Sino pa yung hindi sumasagot? Okay, kompleto na yata. Okay, good. All right, guys. So this is what happens pag nagda-dummify. No? So pag dummify variables, kaya nga guys, importante na mag-a-as factor muna tayo. Yung as that factor, that allowed us to have this regression output. No? That allowed us for R to dummify the variables. So ano yung pinaka-lesson natin dito? Pag meron tayong categorical variables na kailangan natin gamitin yun as classifier or to make it into groups, no? Then we have to convert that as that factor. Pero kung hindi naman, kung may variable tayo na categorical, tapos hindi mo naman siya gagamitin na na classifier, huwag mo na ibigay as factor. Wala nang gamit yun. So we only use that as factor kung yung categorical variables natin is used to classify. Okay, let me clear all drawings first. Okay, then let's go back to our output. Okay, now we can now interpret this. Okay, ano ibig sabihin ng education muna? And it's significant, no? So education is, for every 1 year increase in education, there's a corresponding 57 cents, okay? $0.57 now cents, $0.57 increase in education, ceteris paribus. Don't forget that. Ano ibig sabihin ng ceteris paribus? All things being equal. Ibig sabihin nun, wag mo i-increase sa experience sa tenure, wag mo i-increase tong iba, no? Kasi pag nag-increase ka rin ng experience, may additional change din sa hourly wage. So ang tinitin lang natin dito, the marginal effect of education on hourly wage. Okay? So it's statistically significant, no? Okay, dito, experience 0.02. So it's statistically significant at 10%. So assuming na tatanggapin natin to, no? Which we're not going to accept kasi dapat 5% lang gagamitin natin. Okay, so the interpretation is for every 1 year din kasi ito, no? Increase in experience, there's a corresponding 2 cents, dollar cents, no? Increase in hourly wage. So mas malaki impact ng education, guys. Kasi sa isang year na increase in education, tataas yung hourly wage ng 0.57. Kaya experience, tataas lang ng 2 centavos. Kaya tenure naman, tenure is also statistically significant, no? At 0.1%. Okay, ano ibig sabihin nito? For every 1 year increase in tenure, there's a corresponding 0.138, okay, or $0.138 increase in hourly wage, ceteris paribus. Okay, race white. Now take note, race white is not significant. Okay, si gender male significant, si civil status single not significant sila. Okay, but let's assume that this is significant. How do we now interpret this? So if we interpret race white as this one. So on the average, white people, okay, take note, white people receive around 11 centavos more than their non-white counterparts in terms of hourly wage, ceteris paribus. Let me repeat that. On the average, white people receive 11 centavos, I'm rounding it now, 11 centavos more than their non-white counterparts. Notice how I interpreted this. I interpreted this in relation to the benchmark. Okay, di ba ang benchmark natin dito si non-white? So pag in-interpret ko na to, guys, dapat interpret ko siya with reference or in relation to our benchmark, which is si non-white. Okay, so for the last time, guys, what's the interpretation of this? On the average, white people receive 0.11 centavos or $0.11 more. Bakit more? Kasi positive. Than their non-white counterparts, ceteris paribus. But since this is not significant, we cannot really interpret that way. Kasi sabi natin, pag ganyan, zero yung estimate nito. So, ito naman, guys. Single. Yung male. On the average, male employees in that company receive $1.8 more than their female counterparts, ceteris paribus. And this is statistically significant. Okay? So, pwede mong maitanong dito, meron ba ditong, ano term natin doon? Discrimination, no? Kasi yung mga white, mas malaki, no? Although hindi siya significant. Si male, mas malaki ang nare-receive na hourly wage than their female counterparts. Si single, on the average, single people receive $0.46 less. Bakit less? Kasi negative to. Less than their married counterparts, ceteris paribus. And then on the average dito, okay, although hindi siya significant, no? So hindi natin talaga ma-interpret to. But let's assume that this is significant. On the average, every one child increase in the number of dependents, on the average, increases the hourly wage by $0.15. No? Ceteris paribus. Okay, so that's how you interpret the slopes, no? And the intercept. Yung intercept, paano i-interpret to? So listen carefully, no? Listen carefully. How is the intercept interpreted? Okay, on the average, no? Non-white, female, and married employees with no education, no experience, no tenure, and number of dependents has an average hourly wage of negative 3.39. Ulitin ko yun, ha. Di ba guys, kapag intercept, dapat lahat ng independent variables natin zero. So si education, zero experience, zero tenure, non-white, diba? Ito race white to eh. So pag naging zero to guys, sino yun? Si white, si non-white yun. Yung zero ni male guys is a female. Yung zero ni single is married. Okay? So on the average, yung average salary, hourly wage ng isang tao, ng isang non-white, na female, na married, na walang education, walang experience, walang tenure, walang number of dependents is negative 3.39. That's how you interpret that. Okay, pause muna ako. Any questions, guys? Magtanong kayo guys kasi na-miss ko po yata yung okay, Mariel, kindly share your question para mag-benefit din yung mga classmates natin. Okay, ang question ni Mariel, ito, ano ibig sabihin ng mga to, no? Okay, usually guys, sa economics, ang ginagamit natin na level of significance is 5%. Okay, ito yung ginagamit natin na level of significance. Ginagamit natin yan to assess whether your dependent variable is significant or not. Sa R, makikita natin dito yung asterisk, no? Tatlong asterisk dito, ibig sabihin nun, ito yun, no? Ito, tatlo. Ibig sabihin nun, it is significant at 0.001. Ibig sabihin p-value is less than 0.001. Pag dalawa guys, yung asterisk na nakalagay dyan, significant at 1%. Ibig sabihin yung p-value is less than 0.01. Pag isang asterisk lang, significant at 0.05. So generally guys, dapat at least isang star yung ano natin, yung p-value. Kasi at least significant siya at 0.05. Pag that lang guys, significant siya at 10% na. Eh pag ang standard natin 5%, hindi na significant to. Pero si R pinapakita pa rin. So if we're going to use 10% as our significance level, then pasok to, significant to. Otherwise, kung 5%, itong experience, hindi siya significant. Kasi isang dot lang siya. Dapat at least isang star. Okay? So, clear siya, Mariel?
Sir, thank you po.
Okay, good. Thank you, Mariel, for that question. Okay, very good. Okay, so alright, so dito pinakita din natin, ano? Notice guys, may ipa-point out lang ko sa inyo, ha? Kung yung value ng ano ng estimates natin, ito yung 5% confidence interval to, ano? Kung tatamaan niya yung zero between, hindi siya magiging significant. Take a look at this, education. It's between 0.47 at 0.67. So no way for this to touch zero, no? So that's why it's significant. Ito experience negative 0.022 at saka 0.04, okay? So there's a possibility that the value will be zero. So lahat ng mga tatama sa zero, yung zero in between those confidence intervals, hindi significant yung mga yun. Like this, number of dependents. Negative 0.06 at saka 0.36. So tatamaan yung zero dyan. Okay? Alright, so, okay. It's almost time na. So just a quick comparison. Okay, let's take a look at the results here. So alam nyo na guys yung ano dito, alam nyo kung ano dito yung null hypothesis, no? So dito ang null hypothesis, beta null is equal to 0. So lahat yan, no? Ito beta 1 is equal to 0. Hanggang beta 1, 2, 3, 4, 5, 6, 7. Hanggang beta 7 is equal to 0. Yan ang mga null hypothesis natin dito. No? Tapos meron din tayong, as discussed a while ago, meron din tayo ditong ano. Okay. Dito meron tayo dito yung, ito ano, ANOVA dito, di ba? Ano yung null hypothesis natin dito? Sa ANOVA dito? For this one. Diba? It's beta null, diba? Goodness of fit yan, no? Is equal to beta 1, is equal to beta 2, dot, hanggang is equal to beta 7, is equal to 0. So that's our analysis of variance hypothesis. And we reject the null hypothesis kasi yung p-value niya is practically 0. 0.0000. Ito, no? With degree of freedom natin, DF1, 7, DF2, 518. Bakit naging ang DF1 natin, degree of freedom 1? Bakit degree of freedom 1 is equal to 7? Where did we get this? 7 siya guys kasi ilan ba yung predictors natin? Ilan yung K natin? By education, experience, tenure, race, gender, 7 yun. Okay. Kaya 7 siya. Okay. Ilan naman yung degree of freedom 2? Remember guys, it's N minus K minus 1. N natin is 536 minus 7 minus 1. Yung 1 na to, it's to compensate for the lost degree of freedom because we're going to estimate yung intercept. So 536 minus 526 pala, sorry. Minus 8, so that's 518. Okay, so this is our F stat. And then notice guys yung adjusted R squared natin. Kanina 0.16 lang. Ngayon 0.36 or 0.37. What does that mean guys? Tumaas yung coefficient of determination natin. Ibig sabihin guys, ngayon 36.19% of the variability of your independent variable can now be explained by your independent variables. So tumaas yung explanatory power ng model natin. Kanina 16% lang. Ngayon 36% na. So mas maganda guys yung model 2 natin. So mas maganda yung sinama natin lahat ng variables. Okay, and lastly guys, before 2 minutes lang tayo, no? Kunin natin AIC guys. Okay, just these last two guys, sorry. Extend lang ako 1 minute guys. No? If we run this, okay, sorry. BIC to. Okay, Hakaike at saka yung Bayesian. Sensitive siya sa capital letters. Alright, yan. AIC guys, 2777. AIC ni Model 2, 2640. So, ibig sabihin guys, mas okay si Model 2 kasi mas mababa yung AIC niya. Mas mababa din yung DIC. No? Last guys, okay lang. Can I have 1 minute guys just to run this? Yung dulong-dulo na to. Do I have your permission guys? Kasi 11 o'clock na. 1 minute
Yes, sir.
guys. Okay, thank you Ito lang. Para hindi na tayo mag-briefing dito. Para next meeting guys sa Friday, bago tayo magsimula guys, i-load nyo na kagad. I don't have to inform you. We'll pick up with model number 3. Dito tayo sa model number 3. I-run natin guys yung ANOVA. No? Ang gagawin natin dito, i-compare natin which is better, model 1 or model 2. If we use ANOVA, model 1, remember model 1 is called your restricted model. Bakit siya restricted? Mas konti yung predictors niya. Diba si model 1, ano lang siya, simple. So isa lang yung predictor niya. Si model 2 is 7 predictors. So ang null hypothesis natin dito, restricted model, model 1 is better. So mas maganda ba talaga si model 1 kung isang predictor lang gagamitin natin? So let's run this. Okay. So take a look at this guys. Model 1 natin, yung restricted. Hourly wage, regression education. Model 2, hourly wage regress on the 7 independent variables. Okay, then we have this, p-value. Dito natin titignan guys. P-value, dito. Here. P-value is, ano to? This is practically 0, di ba? So this is 0.00000, 15 zeros and then 22. Okay, so this is 0 and then significance siya at 0.001, 3 stars to. So what's our conclusion? Since the P is much less than 0.05, then i-reject natin. Reject natin si null hypothesis. Ano yung null hypothesis natin, guys? Mas maganda si restricted model. Yan. So is the restricted model better? No. Reject natin siya. So mas maganda si model number 2, yung unrestricted na model. So in this case, we were able to statistically compute and show that model 2, the unrestricted, yung mas maraming predictors, is better than model 1, the restricted model. Okay? So, all right, let me clear this. Let me stop recording now.